Welcome everybody, and thank you for attending today's Parasoft presentation on what's new in our latest release of C C++ test version 21.1. My name is Ricardo Camacho and I'm a technical marketing manager for Parasoft. I'm also accompanied by product manager Miroslav Zielinski. Hey Mirek.
Hello everybody, it's truly a pleasure to be here today.
Thank you, Mirek. Now before we get started, let's go through some housekeeping. First, everybody's microphone has been muted. However, if you have questions, please enter them into the question dialog box. Also, if you run into any technical problems, like not being able to hear audio during the presentation, you can also use the chat. There you can connect with one of our team members who is ready to respond. Also, this presentation is being recorded and will be made available typically within 12 to 24 hours. On the agenda, I'm going to start with a very quick introduction to Parasoft. Some of you may be new to us, so I want to make sure you become aware of who we are and the solutions that we offer. We will then dive into the new capabilities and enhancements. I've listed some of those key features. And then Mirek will deliver a live demonstration of our C++ tests, GitHub integration, and CMake as well. And then we will finish it up with Q&A. All right, so let's get started. Parasoft has been in the software industry for over 33 years, leading the industry in automated software testing, with a strong focus on offering the solutions needed by software companies and achieving standards compliance for safety and security critical systems. Our headquarters is located in beautiful Monrovia, California, and we have various offices around the world. So no matter where you're located, there's always a Parasoft representative in your time zone, willing and able to accommodate any request that you have. Also, we have a very broad product portfolio covering everything from a comprehensive set of static analysis solutions to unit testing and other testing methods, and up all the way through not just in the embedded space, but also in the enterprise IT space. So this actually puts Parasoft in a unique and advantageous position worth knowing a little bit about. So I will quickly talk about both of these software testing domains, but another key point is that all of our products in our portfolio are built by Parasoft. So they are not acquired products. Therefore, the integrations between these products are seamless. So this slide gives you a visual of the software domains embedded in enterprise IT and the industries that Parasoft supports. You can see the automotive, military, rail, medical, and industrial automation for the embedded space. And we also support financial or banking services, hospitality, healthcare, and insurance, and other IT industries as well. So let's take a closer look at our unified solution. For embedded, our customers are generally trying to satisfy their industry compliance requirements, such as automotive ISO 26262, avionics, DO 178B and C, and others. Now, Parasoft provides the testing methods defined in these process standards, testing methods like static code analysis, which we support MISRA, AUTOSAR, CERT, CWE, and many other coding standards, or you can configure your own custom in-house coding standard. Also very important to know is that we easily integrate within your embedded ecosystem. We help you test on your host, virtual, or target hardware. We support an extensive list of compilers, and we integrate with numerous IDEs. IDEs like Eclipse, Visual Studio Code, Code Composer, and the list is just very comprehensive. We also automate your unit integration and system testing, help users perform structural code coverage, statement, branch, MCDC, and yes, assembly language as well. And other types of testing, which some of them fall in the IT space, like API testing, UI testing, and service virtualization. And of course, we support other coding languages besides C and C++, like C#, Java, and VB.NET. Now, to help you visualize our solution offering, we have put a map or mapped this into the actual V model, which is very common in the embedded space. On the left side, you can see where our integrations with requirements management tools like Jama, Codebeamer, Polarian, and others exist. Newly added is Lattix, which I'll be discussing later in a different slide. Now on the right-hand side of the V, you have all of the testing solutions offered by Parasoft. Extremely important to know is that Parasoft solutions improve productivity, reduce effort and labor costs, shortens time to market, and it does this through the automation and simplification that we deliver. One final bit of information is that Parasoft solutions like CC++ test are TÜV certified. So they're TÜV certified for use on safety critical applications, and Parasoft also offers a tool qualification kit available for meeting standards like DO 178B or C. Okay, I think you've gotten a good foundation on Parasoft to build from, so let's dive into the exciting new features that have been added to CC++ Test 2021. Now, we're going to start with the enhancements to Git-based workflows and CI/CD integrations, followed by enhancements to the way users can deploy CC++ test, then compilers and environments being supported, and then we'll go into a whole other set of new features because it just keeps getting better and better. We can keep adding. Now, Parasoft loves to make things simple so that our users have time to tilt back and relax. Miroslav will actually be demonstrating this, so I don't want to take away from his thunder on these Git-based workflows. So I'm going to scan through this kind of quick here. Now, in the GitHub Marketplace, you will now find a Run Parasoft CC++ Test action, and in the description, you're going to find useful examples of how users can integrate CC++ tests into their GitHub workflow, providing valuable information, as you see here, that will help streamline tool integration and configuration. Additionally, we have added Serif format reports for static analysis. These code analysis reports are automatically consumed by GitHub and presented natively in the code scanning alerts interface. Therefore, these reports become intuitive and a natural part of the GitHub ecosystem, a fantastic ability to review scan results or alerts directly in the actual GitHub interface. And you can do this either in the check-in or pull request. Now, this streamlines the development workflow, improving productivity and cuts costs. Today, these workflows seem to include VS Code more and more often. So we have continued enhancing our extension for it. So in this example here, in our new release, we have added a new command that imports static analysis results straight to VS Code editor directly from the CI/CD pipeline. There is a GitHub dedicated version of this command which automatically recognizes the current repository and identifies the corresponding or latest static analysis results for it. There's also a generic version of this command that can be used with other CI/CD systems like Jenkins or GitLab. One of the great benefits this provides to users is that they can identify and fix static analysis violations detected as part of the CI/CD process, all while they are using their preferred IDE. This again improves productivity. I do have to say that with all of these enhancements that play together, we really have an exceptional modern development workflow solution offering. Last year, we started moving towards archive-based installers, and we provided a preview version. For this release of CC++ Test Professional, we are making it official. This means that not only are these the primary installers for the product, but the installers themselves will be covered through TÜV certification. This modernizes the installation process and makes it easy to customize the installation script as needed. Then you can perform a security scan, rezip, and redeploy. And it makes it easy to redeploy this to perhaps if you have hundreds of developers. We are always adopting new compilers because embedded ecosystems are always evolving. So one of the most important newly added compilers is the IAR-BX ARM. This is IAR's Linux version of IAR's popular ARM cross-compiler. We also added QNX, QCC 8, and Greenhill's ARM, which both are very prevalent in the automotive industry. And we also added TI's ARM 2028.x compiler and support for TI's Code Composer version 10 IDE. So yep, the IDE as well. Now the next collection of enhancements relate to static analysis, but also architectural design analysis by way of integrating with Lattix Architect. So Lattix Architect helps you understand, define, and control your software architecture. With Lattix, you can create a modular hierarchical view of the system, which allows you to keep dependencies to a minimum and controlled. Users can also enforce the architecture through automatic detection of rule violations, which also help control code complexity. So Lattix Architect relies on code analysis data produced by C C++ test and then offers its unique matrix visualization based on dependency structure matrix or DSM technology to quickly identify and remediate architectural issues. So this unification also complements our continued theme of supporting modern workflows and CI/CD pipelines. Lattix in combination with C C++ test can be coupled with your CI DevOps pipeline, allowing teams to continuously maintain a modular architecture without undesirable architectural deviations. And Lattix offers a heat map, which aggregates Parasoft's code coverage and static analysis from C test, along with architectural findings into one holistic view of code quality, exposing compliance gaps and therefore business risks as well. Now, there's just more content to cover here that I can give it justice. So if you want to learn a lot of the details regarding this solution offering, we have an on-demand webinar available. Just follow the QR code to our Achieve Faster Compliance to ISO 26262 with Lattix and Parasoft in a GitLab CI pipeline. That's a long title there. But anyways, you're going to love that webinar. Now, Parasoft is always trying to stay ahead and incorporate lots of value into our code analysis engine. So we have added new rules that support features found in C11 and C19. We have also added 2 new security configurations to help you achieve security compliance for the DISA STIG standard and for the OWASP 2019 API security standard. Now, it's important to note that meeting compliance to these 2 standards is more than just performing static analysis. These standards have guidelines that cannot be met solely through static analysis. And also, as the C++ language continues to evolve and users adopt the latest edition of the language for their project, parsing errors occur due to gaps in support of these modern C++ language features, which can also block users in their testing effort. So we have updated our EDG parser, which includes complete support for C++ 17 and provides the majority of C++ 20 features. This enhancement eliminates known parsing problems, which prevent the successful execution of static analysis sessions and code coverage instrumentation. Yes, there is more, and I'm actually excited about the next integration that I'm going to mention. Parasoft has built an integration with Jama Connect, an ALM and requirements management platform. Following the flow that you see in the diagram, requirements are authored in Jama. Then our Parasoft DTP, which is not just a dashboard and reporting solution, but also an integration hub, has an bidirectional integration with Jama, where requirements can be imported. Then in C test cases can be created and linked to requirements for traceability and validation of the requirements. After test execution is performed in C test, the test runs and test results automatically flow into DTP and into Jama, keeping everything in sync. Therefore, the integration with Jama offers a complete software requirements verification validation solution to help you satisfy process standards like DO 178, ISO 26262, and others. Also, the integration allows for defects defined in Parasoft to be exported as issues or defects in Jama, allowing Jama users to manage all the identified defects. Now, This is something that Merrick's going to cover in his demo. We have continued to notice growing use or popularity in CMake, and because it's important to us in providing value to our customers, we have continued to make incremental enhancements to this integration to further make it seamless. We have extended it to enable support of structural code coverage for integration and system-level testing, and users can merge the coverage obtained through these and other methods like unit testing. The integration has been simplified and automated by way of test scripts, and therefore instrumentation for code coverage can be automatically added during the build process. So let's get to the fun stuff and see how Parasoft integrates into GitHub workflows and CMake. Over to you, Merrick.
Thank you, Ricardo. Great overview of our release. Hope you can see my screen.
Yes, we can.
So now let's see some of what Ricardo was talking about in action. I'm going to show you two things. We will see how C C++ test GitHub integration simplifies building static analysis workflows and improves developers' productivity. And we will see streamlined code coverage integration into CMake projects. For GitHub integration part of the demonstration, we're going to see how easy it is to create a GitHub workflow with C C++ test static analysis, how to access static analysis results in GitHub, and how to download results from GitHub account to VS Code for convenient demonstration, for convenient remediation. In the second part of the demonstration, we'll focus on the code coverage extension for CMake, and I will walk you through the process of integrating code coverage with an existing CMake project. We'll see how to generate code coverage reports and browse the results using IDE, and we'll see how to add unit tests to supplement system-level testing code coverage. So let me bring my demonstration environment, and for my demonstration I will be using Linux virtual machine, Linux desktop with GNU GCC compiler, C++ test, and CMake. I will be also using my GitHub account where my demo project is, and I will be using a GitHub self-hosted runner that is configured in my development environment for executing build and test pipelines. So here is my GitHub repository with the example project, and my goal now is to add a workflow with the static analysis, for example, to enforce MISRA or AUTOSAR compliance, or simply to hunt for bugs. So to add a workflow, I need to go to Actions, click New Workflow, and then set up a workflow yourself, which takes me to this panel where I can define the new workflow. And the process of adding new workflow with C C++ test static analysis is now simplified thanks to the dedicated action, which can be found in the marketplace. So I'm switching to the marketplace panel. Let me type Parasoft here, which will show me the action, run Parasoft C C++ test, and we can drill down here to get more details. And the action, the description of run Parasoft C C++ test action contains examples of workflows, including workflow example for CMake-based projects, which happens to be used also for our demo project. So let me copy the content of this workflow. Let me go back to this panel, and let me paste the new workflow. And before we commit, let me quickly walk you through the content of this workflow. The workflow is prepared to trigger on push and pull request events It is prepared to be executed on master or main branches. Of course, this is something that can be customized. This example workflow contains one job with several steps. Here you can see we have a step for code checkout. Here we are generating build scripts with CMake, and we are using a special CMake feature here, which exports JSON file with compilation command lines, which is an input for the static analysis process. Then we have the build step, and here we have run Parasoft C++ test action, which automates the static analysis process. As you can see here, the action takes the compile commands JSON file generated by CMake as an input and performs the analysis. After the analysis, static analysis report in the SARIF format is uploaded to GitHub, which enables static analysis findings in GitHub as code scanning alerts. And finally, we are archiving other reports files for later use. So let's commit our workflow. And take a step back. And as you can see, the commit operation already triggered the workflow. This little dot here indicates that the workflow is running. So let me take a look here to see some more details. We see that the workflow is in progress. Project is now configured. Build scripts are generated with CMake. And now C++ test executes static analysis. The default configuration for the run Parasoft C++ test action uses Parasoft recommended rules selection of static analysis checkers. Of course, this is something that can be easily customized. Action takes parameters, and users can specify any other of the built-in C++ test configurations or custom selection of static analysis rules, static analysis checkers to be enforced on the project. Analysis is just about to finish. And once this is done, our workflow will upload the SARIF static analysis report, which, as I already mentioned, will make the results available in the GitHub interface. So this is in progress now. As you can see, we have 5 static analysis findings, and right now the report is uploaded. So I'm ready to go to the security tab. And if I click on code scanning alerts, GitHub displays all the static analysis findings. If I want to get more details, I can click here, and I'm presented with a code snippet that points to the place where the specific problem appears, and I have a helper comment that explains the why and where the problem appears. If I need more information, I can click here, show paths, and I'm presented with a collection of steps decorated with source code snippets and some additional helper comments, which shows me the path in my project, in my program, for unwanted situation. In this case, we have a possible access of array out of bounds. So this information helps me to understand the problem and remediate it. So let's see now another interesting use case of our GitHub integration. For this, let me bring up Visual Studio Code editor. Here I have my project pulled from the repository. Let me make sure I'm using the latest version. Okay, go back here. And the great new feature that Ricardo was talking about that we added in this release is ability to download the static analysis findings generated in the CI/CD pipeline. So let me now use this command, load results from GitHub, and C++ test extension for VS Code now connects to my GitHub account and downloads all I need to know to remediate the problems. And the great thing here is that the extension understands which GitHub repository I'm using. It understands what's the branch I'm currently working on, and it identifies relevant information in the GitHub and downloads the relevant static analysis results. So let's simulate that we are remediating some of the problems, and let's do some quick fixes here. This specific problem is about the referencing the pointer before it is checked. So I need to move the if statement few lines above. Okay, this should do the trick. And let's say that, I don't know, I have another problem which I want to suppress because I don't want to fix it now. So I will use another action. I need to type a reason. Acceptable, basing on permit XYZ. Suppress, and this added a comment. So I'm ready now to commit my code. Static analysis applied. Save and commit, and I'm ready to push my changes to repository. And as you remember, my workflow is prepared to be triggered on a push operation. So if I go back to GitHub, I see that push operation triggered the workflow, and static analysis is already in progress. Once it's done, I will be able to review the results again in GitHub or download them for remediation in the VS Code editor. So this concludes the first part of our demonstration, GitHub integration. Now I would like to switch to the second part of our demonstration, which will be focused on our new code coverage extension for CMake. So let me switch to the console window. This is where I have a timer project, the same one we were using for GitHub integration demonstration. And let's say that, let's assume that for this project, I have a collection of system level test cases, test scenarios defined somewhere in my requirements management systems. Of course, test cases, test scenarios are correlated with requirements. And my goal now is to add code coverage to my project to get a better understanding of the testing process thoroughness, to understand where are the testing gaps and where I need to focus my testing process to make sure I'm providing reliable software. And with the new release, C++ Test provides a new extension for CMake, which simplifies the code coverage integration process. And all that needs to be done now to integrate code coverage into CMake project is basically adding one line, the line I'm hovering over right now, which includes the CMake extension that is shipped with C++ Test. I have here a conditional statement to make this include parameterized, but that's not necessary. So with this, my code coverage extension is added to the project. Let me save, quit, and now I'm ready to build my code. So let me create a directory. Let's name it build coverage. Let's switch to this directory, and let's generate build scripts using CMake command. Here you can see I'm using two helper variables. The first one enables the code coverage extension, and the second variable, which is required, provides the information about the installation location of C++ test. So let's actually generate build scripts, and I'm ready to build my project. So I will call make, and timer project is now built. And the build process includes source code instrumentation for code coverage. This is what happened under the hood when the build scripts were generated with our CMake extension. So we are ready to start our system level testing. The binary, the program is here. It's called timer, so I can start it. And let's say that my test scenario requires I add one timer. So I'm selecting option number 1. Let's say that I want to start at 10 sharp, and I want to finish at 11 also sharp, and I want to record data from channel number 4. And that's it. And this concludes my test scenario. And now I'm ready to generate code coverage report and to see gaps in my testing process. And the great thing is that the extension also adds a helper build target, which automates the report generation process. So the target is named CPP test coverage report. It's in progress now. C++ test combines the static source code maps generated during code instrumentation with the dynamic code coverage results generated during my system level testing, and produces code coverage reports. Here on the console you can see a short summary with some percentage numbers for different types of code coverage metrics. But the extension does more. It automatically creates workspace and a project which can be opened with IDE, with C++ test for viewing the data. But it also generates HTML code coverage report, which we can see here. Let me reload it. Here we see, I just realized this is font is really small here, but hopefully you can read it. Here we see a summary of the code coverage metrics, and the information is displayed for each file from the project, and the statistics are broken down to the level of individual function. So we can use this HTML report, but as I mentioned, we can also use IDE as a code coverage viewer. Here we have the project that was automatically created by the extension. If we open code coverage view, we can get some more information. Let's say we want to inspect the timer.c file. So we see the highlights in the code. These are all the lines. The green lines are all the lines executed by my functional testing. But I see that not all the lines were covered. I see that we have some gaps in the testing process. This is a good example at timer function. We see here in statistics that we have a pretty high code coverage. We have 83%, but not all the lines for this function were executed. Specifically, here we have one line which is error handling path through the function, which is executed only if we have a problem failure in querying user information. So this function returns null, and these kind of situations are not always trivial to, it's not always trivial to stimulate the software during system level testing to execute these kind of branches in the code. So this is a perfect application of unit testing. What we can do now is we can add a unit test for add timer function, and we can also add a stub for query user to force it to return null, which indicates a failure in our system. And then we can check if error code is returned as expected. So actually, let me quickly do it. I will start with generating the stub. For this, I need to collect stubs information. So I'm using a dedicated test configuration which scans the project and prepares it for adding stubs. Once this is done, stubs view will be populated with the information about the symbols. So I can search now for query user function. It is here. Let me resize it so it's easier to read. As you can see, right now we are using original definition of this function. Since we want to simulate a failure, I want to create a user stub. Let's name the file fault injection. It will generate a skeleton. It will generate a stub body for us. We don't need to edit it. We'll configure the stub from the test case. So now I'm ready to add a test suite for my file. So again, I will use a dedicated test configuration, generate test suites, which will create an empty test suite. And I will use a test case editor. I will use a test case editor to add a test case. So let me do it now. Add new using editor. Let's stay with the default name. And the test case editor is now opened. Let me put these windows side by side so we can see the source code while adding the test case. Okay, and we'll add a default test case for add timer function. Our function does not take any input parameters, so the test case is relatively simple. It is using some global variables, but we are fine with the default initialization for those globals. What we want to do is we want to configure stub. So I will add a stub configuration step. Here we see the function we want to stub. And what we want to do is we want to make sure that return from the function is null. Right, so this is one thing, and then we want to make sure that for this stub configuration function returns error code, and we can remove those two assertions that are not required. So let me save this test case, and we are ready to execute it. So I will use another test configuration, run unit tests. C++ test builds the test harness. Oops, I made a mistake somewhere. Okay, I see where it is. Return. Now it should be fine. Let me save it and let me run it one more time. Hopefully no surprises. So again, build harness is now, test harness is now built. test case was executed. As you can see, test case status is okay, and we have combined, merged system-level testing code coverage and unit testing code coverage. And for the function we were focusing on, we have 100% of code coverage. And this concludes the demonstration part. So let me, for a moment, go back to my slide deck and quickly recap. For the GitHub part of our demonstration, we've seen how easy it is to create a GitHub workflow with C++ test static analysis, how to access static analysis results in GitHub, and how to download results from GitHub to the VS Code for convenient remediation. For code coverage extension for CMake, we've seen how easy it is to integrate code coverage with existing CMake build, how to generate code coverage reports and browse the results in IDE, and how to add unit tests to supplement system-level testing code coverage. And with this, Ricardo, back to you.
That was excellent. I always love your live presentations. They really give a very clear view of our products and solutions in action. Anyways, what I want to say is that you can follow us on Twitter, Facebook, YouTube, LinkedIn, or if you have any questions, please email us at info@parasoft.com. And for those of you that want to try our products, take a snapshot of the Try Parasoft QR code. It will take you to the landing page where you can also request a custom demo. And for our existing customers, you can visit the Parasoft customer portal so you can download the latest C++ test 2021.1. But, just in general, I recommend that you visit our website. We offer lots of educational content and events that we give out, like we do a monthly demo. We've got webinars, and we actually have a lot more. I thank you very much for attending today's webinar.
Thank you very much.
Bye-bye.